Hello, this is Mr. Brown. This podcast today is for the intro level CNT classes. This is just a quick review on our number conversions that we'll be dealing with. In networking, you commonly deal with binary and hexadecimal numbers. So what we want to do today is remember what we know about decimal numbers we use every day. Start applying that to binary, where binary we're typically going to find that, well, that's how computers communicate, that's how routers communicate, that's how switches communicate. So it's kind of nice to recognize that. But we often work with this as we start dealing with subnetting and IP address management. A lot of times we'll work in the binary realm to help us figure out how many bits are being borrowed, that sort of thing. So it'll be handy to have that. Hexadecimal, well, hexadecimal you find in MAC addresses, but we don't often work with MAC addresses very much, as in doing much with them other than recognizing what they are. But where you will find hexadecimal is when we start dealing with IP version 6. So we want to get a little bit of handle on that, so as we start dealing with IP version 6 addresses, we know what we're looking at or what we're dealing with. All right, so let's start with what we know. And what we do know is our base 10 number system, decimal number system. So decimal number system, we typically call that base 10. And it comes base 10 because we have 10 digits. 0 through 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's our 10 digits. And our place values, as we learned in elementary school, are the ones column, the tens column, the hundreds column, thousands column. That's probably how you learned them. And eventually, when we started learning algebra and exponents, we understood or realized that 10 to the 0 power is really the ones column. That's how you get that. 10 to the exponent or power of 1 gives us the tens column. 10 to the power of 2 is 10 times 10, which is 100. 10 to the 3, which is really 10 times 10 times 10, which is the 1,000. So there's our base 10 decimal number system that we work with every day. And eventually, you got good enough at this, the teacher gave you a number like 1, 2, 3. While you first start off learning, this is really 3 ones, 2 tens, 1 100, and the teacher would literally have you add them up. 100 plus 20 plus 3 equals 123. Well, we know that so well now today, we jump right to the chase and say that is 123. And we also know that if we add a 0 out here at the beginning of the number, that really doesn't affect the value of it. It doesn't matter on my paycheck if there's a 0 under it, it doesn't matter. That does not affect it. So as we're working with numbers, if it's comfortable for you to put a 0 out on the front to make it a full byte or something like that, that's fine. It's not going to affect it. But we also know that if we put a 0 back here behind the number 1, 2, 3, we now make it 1, 2, 3, 0. We have changed the value of it. I often joke it'd be nice to add a 0 behind my paycheck. That'd be kind of cool. But that it changes the value of the number, so we cannot do that. We can't put a 0 back here. Sometimes people get tempted to do that, and I like to remind them, no, we can't do that in decimal, so we're not going to do that in binary number system either. All right, so keep those things in mind as we start applying it to a new number system. Well, the new number system we want to look at first is our binary number system. And our binary number system is really called base 2 because we're using the digits 0 and 1. And our place values really are 2 to the 0 power, which is the ones column, 2 to the 1 power, which is the twos column, 2 to the power of 2, which is 2 times 2, which gives us the 4 column, 2 to the power of 3, which is 2 times 2 times 2, which is the 8 place, and so forth. And we very quickly see that our place values are doubling as they go. 1, 2, 4, 8, 16, 32, 64, 128. Typically, that's the place values we worry about because that is 8 place values, which would be 8 bits or a byte. That's typically enough to do what we do in computers, if you will. There is additional place values. 2 to the 8 is the 256 place and so forth. It does continue, but typically 8 bits or 8 place values is enough to do what we want to do. So there's our binary number system. All right, well, let me convert the place values over to here, and let's do a problem or two to make sure we start getting a handle on how to do this. So let's put the 1 place, the 2 column, the 4 column, the 8 column, 16, 32, 64, 128. There we go. There's our place values. Let's start out with a simple binary number of 1010. Well, all we really have to do is what we did back in elementary school, start adding up these place values, if we will. The 1 times the 8 place is actually 8. 0 times the 4 place is actually 0. 1 times the 2 place is 2. 0 times the 1 place is 0. So 8 plus 2 equals 10 in decimal. So there's the number 10 in decimal. Well, it doesn't take long to figure out that I don't actually have to do the 0 times. 0 times the 4 place, 0 times the 1. It doesn't affect the number. I can really come and take these place values that have a 1 in, add them up, and I get the same result. It's a lot quicker. So we're going to look for any place values of 1 in, add those up, and we'll get our decimal equivalent very quickly. So there was the first one. Let's do 1 or 2 more to make sure we got it. Let's do this one here. Let's go. Okay, so we now have 1, 1, 0, 0, 1, 1. Well, we don't need to worry about adding the place values with 0 in, but we are going to add up the place values with 1 in. So I want to take the 32 place, so let's go 32 plus 16 plus 2 plus 1, 2 plus 1. When I do that, 6 plus 2, 8, 9, 10, 11, 3, 4, 5, we end up with 51. That is the decimal number 51. 51 in decimal. Okay, so add up the place values of 1 in, and you got it made. Let's do one more. Make sure we got it. Okay, or you can, watch it to see what we're doing. Let's do this one now. We're going to do zoop, 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 zoop. So we now have 1, 0, 0, 1, 1, 0, 0. Let's add up those place values. This time we're going to take our 64 place plus 8 plus 4. Okay, so 64 plus 8 plus 4. All right. So 8 plus 8 here gives us 16. 6 plus 1 is 76. Okay. So this number here, 1001100, is the decimal equivalent of 76. So any place value with a 1 in, add it up, you'll get the decimal equivalent. All right, well, let's start going the other direction now. Let's take a decimal number and come up with a binary equivalent. Well, to do that, I'm going to subtract my place values now. And any place value I subtract, I'll put a 1 in. So let's start with the number 48. We'll keep it small to start with. And we'll start with the number 48 here. And we'll start subtracting place values. Any place value we subtract, we'll put a 1 in. Well, I can't subtract 128. I can't subtract 64. But I can subtract 32. So when I do that, I'll put a 1 up here indicating I'm using it. So 48 minus 32 gives us 16. So I can subtract 16 now. I'll put a 1 up there and indicate it. I'll subtract 16. I end up with 0. Well, I can't leave these hanging. I do need to indicate what those are. I need to put placeholders in, so I do need to put 0, 0, 0, 0. Again, I would be annoyed if the boss took those zeros off the back of my paycheck. That's not my paycheck, by the way. But I would be annoyed if those disappeared, so I cannot get rid of them now. I need to put them in as placeholders saying we're not using them. So there is my binary equivalent to 48. All right, let's do another one. Let's take the number 93. And again, we'll start subtracting place values. I can't subtract 128, but I can subtract 64. Okay, so I'll indicate that I'm using that. So 64. When I subtract 64 from that, I'm left with 29. Okay, I can't subtract 32, but I can subtract 16 from that. 29 minus 16, I'm left with 13. Okay, so now I can actually subtract 8 from that, so I'll indicate so. So 13 minus 8, all I did was transfer it up there so you can see what I'm doing. 13 minus 8, I'm left with 5. I can subtract 4 from that. I'm left with 1. Can't subtract 2, but I can subtract 1. I'm left with 0 there. So my binary equivalent to this guy, 1, 0, 1, 1, 1, 0, 1, is my binary equivalent to that, to 93. All right, one more time. Let's do a little bit bigger number. And we'll do, this time, we'll do the 156. Squeeze this over here, 156. Okay, so 156. I can indeed subtract 128 this time, so I'll indicate that. I'll subtract 128 from that. When I subtract 128, I get 28. So I can't subtract 64. I can't subtract 32. I can subtract 16. When I do that, I'm left with 12. I can subtract 8 from that. So when I do, I'm left with 4. 12 minus 8 is 4. So I'll transfer it up here. 4. I can subtract 4 from that. I'm left with 0. Don't leave these hanging. Put the placeholders in. So there would be my binary equivalent. 1, 0, 0, 1, 1, 1, 0, 0. There is my binary equivalent to 156. So there's a quick overview of binary number system base 2, and how to convert from binary to decimal, and then decimal back to binary. Binary to decimal, add up your place values with 1 in. Decimal back to binary, subtract the place values, indicate the place values you use with a 1, and put zeros in the place values you do not. So there, real quickly, is my binary number system. All right. The other one we want to hit with you guys today is hexadecimal. Okay, so hexadecimal, also called base 16, because I use 16 digits, 0 through 9, and then I start using A, B, C, D, E, F. And each of these letters represents the next number in our number string. A is representing 10, B is representing 11, C is representing 12, D is representing 13, E is representing 14, F is representing 15. It's a shorthand. Less characters to represent larger numbers. And that gives us basically 2 bytes, if you will, because I have 16 digits. I basically have 2 bytes. My place values, again, 16 to the 0 is the 1 place, 16 to the 1 is the 16 place, and 16 to the 2 would be 256. That place value exists, but we don't often use that, so we normally stick with those 2 place values there. The 1's column and 16's column, if you will. So there's base 16. Now, let's look at a couple numbers with hexadecimal and work with them. So I'm going to transfer my place values over here. Let me kind of squeeze it over this way. We'll do 16 to the 0, which is the 1's place, and we'll do 16 to the 1, which is the 16th place. There's my 2 hexadecimal place values. Well, the first one we're going to do, let's just take a good old hex number. Let's do B3 here. And we want to figure out what its decimal equivalent is. I'm just going to write it this way. What its decimal equivalent is of that guy. Well, to do that, all I really need to do is take these numbers times the place value and add them up. Well, 3 times the 1 place is indeed 3. B, which is 11, we're going to take 11 times the 16 place. So we'll actually do 11 times 16. When I do 11 times 16, 1 times 1 is 6, 1 times 1 is 6, 1 times 1 is 1, 1 times 1 is 1. I end up with 176. So 176, squeezing off the bottom down there, 176 down here plus my 3 gives me 179 in decimal. So multiply by place values, add them up. And there's the first conversion. Let's do another one. Okay, we'll do, I'm going to slide this up a little bit just so we have a little bit more room. Here's our 16's place, there's our 1's place. Let's now do C7. C7. And again, we want its decimal equivalent over here, decimal. So C7, I'm going to take 7 times the 1 place, which gives me 7. And I'm going to take C times 16. So I'm going to take 12 times 16. So 12 times 16. When I do that, 2 times 6 is 12. 1 times 6 plus 1 is 7. So we got 72 there. 1 times 12 is 12. Here we go. So 2, 7 plus 2 is 9. We have 192 plus the original 7. 192 plus 7 gives us 199 in decimal. So C7 in decimal is 199. Multiply by the place value, add them up. All right, let's do one more. Let's do one more to make sure we got it. Last one we'll do here is let's do D5. That sounds like we're playing Battleship. You sunk my battleship. All right, D5. We're going to take 5 times the 1 place, which is 5. D times the 16 place. Well, D is 13, so we're going to do 13 times 16. When I do that, 3 times 6 is 18. 1 times 6 plus 1 is 7, so we got 78 plus the 13 here. So 8, 7 plus 3 is 10, so we get 208. 208 plus the existing 5 gives us 213 in decimal. Woohoo! So multiply by the place value, add them up. We just need to remember A is 10, B is 11, C is 12, and so forth. Okay? Well, what if I have a decimal number and I need its hexadecimal equivalent? All right? Well, let's leave that number there because we know 213 should equal D5. But let's take 213 and show the math to get D5. All right? So let's now take 213 and we're going to do basically elementary school division. 213 we're going to divide by the highest place value we can, which is 16. And we're going to do division like we did in elementary school where we had a remainder. So I want to take 213 divided by 16. I can do that 1 times 16 here gives us 16. I'm left over with 5. Bring down the 3. Remember doing that? 53. Now I can go 3 times. 2 is 32. 3 is 48. So 3 times 16 gives us 48. I'm left with 5. So this would be 13 remainder 5. Well, 13 is D. Remainder 5 is 5. So there's D5. 13 remainder 5 is D5. That's how we do it. We do division like we did in elementary school and write it back in a hexadecimal number. All right, well, let's do 1 or 2 more and get its hexadecimal equivalent. Let's take the decimal number in this case. Let's take the decimal number 178. Okay, 178. And we're going to divide by 16. So let's do 178 over here. Divide by 16. So 1 times 16. I'm left with 1. Bring down the 8. 16 goes into 18 one time. So 1 times 16. I'm left with 2. So I have 11 remainder 2. 11 in this case is B2. So I have B2. That kind of got squished in there. 11 is B, remainder 2, so I have B2. That is my decimal or my hexadecimal equivalent to 178. Sorry, I got a little squished in there on that one. Let's do one more. Okay, let's do 152. Let's take 152. 152 in decimal. What's its hexadecimal equivalent? So let's take 152. Divide by 16. Okay, well, 16 doesn't go into 15. 10 times 16 will be 160, so we have to probably start with 9. 9 times 16 should equal 144. When I subtract that, I'm left with 8. So now we have 9 remainder 8. This hex number is indeed 98. That is the hex number. 152 in decimal equals 98 in hexadecimal. So they don't always have to have a letter in. That is my hexadecimal equivalent. So there is the hexadecimal conversion. Base 16 number system, taking a hex number going to decimal, and then taking our decimal number back to hex. So hopefully this number review, this number conversion review, is helpful for you for CNT120 and CNT125.